We're going through part 2 of the coordinate geometry learning task. Part 2 gives you a background on all of the skills that you will also need for part 3 pretty much. Before we get started, please make sure that you've got your CAS calculator with you. You've got a nice sharp pencil, you've got a ruler, and you've got some paper, and an eraser wouldn't hurt either. So if you could pause the video and then collect that stuff and then come back to it. Alright, if you have a look at part 2, then you're going to find, I'm just clicking it open here on my screen. If you go to part 2 of the coordinate geometry learning task, you're going to find the first thing that you have to do is you have to draw a triangle. The triangle has got the 3 vertices A, B and C. So in this geometry cat, it's really important that your graphs are accurate to get full marks. That is, your graphs have to have straight ruled lines. The scale on them has to be carefully measured. Now this means that if we go over here, this area here, the distance from 0 to 1 should be exactly the same distance as from 1 to 2 and from 2 to 3 and so on. For some reason, a lot of people often have a different gap in here to the rest of the graph. They're pretty good with spacing these other numbers evenly, but not so good with the first gap. Make sure that yours is accurate. Use a ruler. Second thing, make sure you label your axes. So your horizontal axis is X and your vertical axis is Y. When you plot points, you should put their name and their coordinates. So the point A there, I've put its name, which is A, and I've also put in a bracket with a comma separating them, the X and the Y coordinate of that point. I'm sure you all know how to plot points. They're listed in alphabetical order. X first, Y second. X is red down here, 2. Y is red over here, 3. And I've plotted the point. And then I've joined the 3 points up to make out a triangle. So what I suggest you do is pause the video here and draw yours up. But when you draw it, please make sure that this axis isn't some postage stamp size set of axes, that you make it the entire width of your page. It should take up about half the page all up. And that those points, A, B and C, should then make a nice big triangle filling out your page. The bigger and more accurate that's done, the easier it will be for you to get the rest of the assignment correct. I also strongly recommend that you use the same scale on the x-axis as what you use on the y-axis. If you don't do that, if your scales are different, then what you will find is that perpendicular lines will not look perpendicular when you draw them. And then, that means you won't be able to check that you're doing it correctly. Okay, so pause the video and draw that up. Okay, for the next bit, we are asked to find the midpoint. To find the midpoint of the line BC, we can use the rule, and we would be expected to use the rule and show full working. However, of course, we can also estimate that pretty easily. So if you look up here, we have got an x value of 2 for C, we've got an x value of 4 for B, halfway in between them is 3. That'll be the x coordinate of the midpoint. Likewise for the y value, we've got a y value of 1 for C and a y value of 3 for B. Halfway in between them is 2. So to set out the working, we would need to write the formula, we would need to substitute the values and find the final answer. And of course, I'm labeling it as it says in the question, MBC is equal to 3, 2. And of course I can then mark that point onto a line, MBC, and I put its coordinates 3, 2. Okay, so we've now done question 1, question 2, and question 3. In question 4, it says that we've got this line y1, and we need to find the value of m and c for that line. Okay, so it passes through A and it passes through M. So if I rule a line there, come on, you can do it. Right, so I've got some line like that. It's going to be helpful actually if I continue that line all the way up to the y-axis, isn't it? By continuing the graph up to find where it crosses the y-axis, I'm going to have the y-intercept, the c value in the equation, so it'll be a good check. I can also find the y-intercept as well. Unfortunately, the program I'm using here has not allowed me to measure my scale accurately. It looks pretty accurate, doesn't it? But it's not. And I really should be having these two intercepts as being 5, both on the x and the y-axis. And it looks more like just below 5 on the x-axis and almost 6 on the y-axis. So if you've drawn yours accurately, you should get 5 and 5 as your two intercepts. Alright, so I need to find the equation of the line that passes through it. To figure that out accurately, I'm best off using these 2 points. So I'm going to assign x1, y1. I'm going to call that my first point, which is A. And I'm going to assign my second point, x2, y2. I'm going to assign that one to the midpoint, BC, which was the point 3, 2. Same numbers the other way around. My rule to find the equation is y minus y1 equals m, the gradient, x minus x1. And we also need to figure out that m value by using y2 minus y1, the rise, over the run, x2 minus x1. So, putting those 4 values in, I get 2 take away 3 over 3 take away 2, and what I get is negative 1 over 1, or just negative 1. Now I can go back to my y minus y1, equals m times x minus x1, and I get y minus 3 equals minus x plus 2. Add 3 to both sides, and I get plus 5. So as I said, because my scales aren't 100% accurate here, it looks a little bit off there. It looks more like 5.5 on my axes. Hopefully it looks better on yours. To find the perpendicular line, we need to use this rule. M1, the gradient of the first line, is equal to the negative inverse. So we have to flip the gradient upside down, and we have to change its sign. So for example, if we had 2/3 as the first gradient of the first line, then the gradient of the second one, we flip it upside down, the 3 goes on top, the 2 goes on the bottom, and we change its sign from positive into negative. Or if we had negative 4 as the first gradient, Then flipping it upside down, since that's 4 over 1, becomes 1 over 4. And we change its sign. Started off negative, changes to positive. So we already figured out the gradient of that line between A and the midpoint. It was -1. So all we need to do is flip -1 upside down. So -1 is just -1 over 1. Flip it upside down and change its sign. And the second gradient would have to be +1. Now that we've got a gradient and a point on the line, we can use the rule y minus y1 equals m times x minus x1 to find the equation. So I'm going to call that point that it's going through, the point A, my x1, y1. I put the values for that and my gradient that I've just found in, and I get my equation y equals x plus 1. To check that, well, let's start off with our y-intercept, which is down here. And we go through the point there. That line should be a perpendicular line, and it looks pretty perpendicular to me. In question 6, it's talking about restricting the domain of these two lines. Remember that this line here was our y1, and this line here was our y2. So y1 we need to restrict, and it says x is an element of, and then there's a curly set of brackets. We've got x being between 1 and 6. So here's where x is equal to 1. So here we would need a circle there, and the circle would be hollow to indicate that 1 isn't actually included. It's only values bigger than that point. And likewise over here at 6, if 6 isn't actually included, we'd need a hollow one there. So then I'd need to rub out the other parts of the line. Is that going to work? Come on. Let me pick. Thank you. Okay, so this part of the line is no longer part of it. Likewise this one here. Right, for y2, we've been given the domain, that is the possible x values, and we've been given it in the other interval notation. So when we have a round bracket in front of the 1, that means it's greater than 1 but not including 1. When we have the square bracket after the 3, it means that the 3 is included. So it's less than or equal to. So for this line we want to start at 1 but not include it. Come on, you can do it. Alright, start at 1, not include it. So I want to open circle there, and I want to finish at 3, but I want to include it. So this time, when I put my dot at the end of the line, I colour it in. To do this on the CAS, then what I need to do is use the control and equals to pop up this little menu with a greater than, less than, not equals to on the top line, greater than or equals to, less than or equal to, and the one that I'm really interested in the bottom right is the conditional line. That allows me to put in at the end a condition. So I'm going to put in the domain that I'm interested in. Okay, so I get my conditional line, and then I need to go from 1 to 6. So it's 1, again I get control equals to get that menu. I do my less than, put my x in, control equals again to get my less than symbol, and 6. And when I press enter, now the line only goes between the x values of 1 up to the x values of 6. If I type in my second equation, I have to first of all hit tab again. I type in my second equation, which was x plus 1, I'll put in my condition, control equals. Now this one, we had the round bracket 1 up to the round bracket of 3, but the calculator doesn't know what that means. We have to put it in like this. Control equals was a round bracket, so that meant it's only greater than, not greater than or equal to, and the other one was a square bracket, so this time I put a greater than or equal to symbol up to, oh, it wasn't 6 was it, it was 3. Press enter, and there's my second equation. You might notice that these two equations do not really look perpendicular at all, and that's because my scales are different on my two sets of axes on my graph. The distance between 0 and 1 is different on both of the axes. So to fix that, I need to go to menu, then I hit window zoom number 4, and then I go to B, which isn't on the screen. I can scroll down and see it. Zoom square. And when I do that, you'll notice now that the distance from 0 to 1 is the same on both the x-axis and the y-axis. And now you can clearly see that those two lines are perpendicular. Of course, it would be nice if I could just have those labels not on top of one another. So I can just move those around. Move the other label too if I want to. It's going to let me, maybe. Goodness sakes, come on. Okay, so I've moved my labels out the way so I can see things a bit more clearly. Now the last part that it asks me to do is to find the intersection. So to do that, I need to use my menu, Analyze Graph, Intersection. You'll notice down the bottom here it asks for the lower bound. I just need to click anywhere to the left, and then it asks for upper bound, which means I have to click somewhere to the right. As soon as I get past the intersection point, it starts to show up. Press enter or click and it'll stamp it onto my graph, and that would be what I have to take a photo of as part of my assignment. So that pretty much covers all of what you need to do in part 2, and it covers pretty much everything that you have to do in part 3 as well. Probably the only things that we haven't mentioned that come up in part 3 is it talks about parallel lines. So that's where the gradients, instead of being the negative inverse, the gradients are the same as one another. It also talks about finding the lengths of lines. y2 minus y1 all squared plus x2 minus x1 all squared under the square root sign gives us the length of a line. So I'll leave you guys to it. Good luck.